So now, friends, now we are going to discuss about two main points, that is considered as a unification and reduction. So now here, that physicists are still attempting to solve two principal thrusts in physics, that is the unification and reduction. If you understand simple meaning of unification, to unify means what? To combine something. And reduction means what? So as we combine something, that actual thing, if it's in a very big thing or any complex matter, that will dissolve or that will be solved in a very small form, that is called as a reduction. So now here, that unification, that's the attempts to unify fundamental forces of nature. As we just think about that laws given by Coulomb, that is related to the charge, and that law related to that current, that's the Maxwell. So here we have that law combination, and that gives us a relation with that, how that electric field related to magnetic field. So that we unify two different forces, we unify two different laws. One law is related with that electric field and another law is related with magnetic field. So as we unify two different laws, that we call as a unification. That's a simple thing. Now, as we just think about, that's reduction. So first of all, what is a reduction? That's given here. Our related efforts is to derive the properties of a bigger, more complex system from the properties and the interaction of its constituent simple parts. This approach is called reductionism and is at the heart of physics. It means everywhere we are just trying to make it more and more simpler. We want to just reduce that part. If you just think about in a normal case, if you just think about in our day-to-day life. For example, we are using lots of gadgets, lots of equipments. For example, if you think about simple mobile phone, पहले भी mobile phone थे, आज भी mobile phone है. But that size of phone decreases as well as that quality increases. We will get more facilities. So instead of very huge mobile phone, now we are using very small mobile phone, lightweight, and we are trying to get more and more simpler function in that one mobile phone. So here that physics is considered is always just try to minimize or make it a smaller of a very big thing or a more complex things. So if you want to understand physics in a very good way, जो भी difficult part है, just always think at very small scale, just always think at the very simple way. बहुत difficult सोचने की जरूरत नहीं है, simple सा सोचो. Okay, as we just think at the very simple way. If you think at very simple way, so that consider as a reduction of that physics, and that is considered the heart of the physics. I hope you understand. Now next point, that is about the fundamental forces. In physics, here we have four fundamental forces. That first one, that is considered as a gravitational force. We know it very well, gravitational force that exerts between any two bodies in the universe. That force directly proportional to their masses, inversely proportional to square of the distance. If we think about any two body, any two particle in the universe, there is a gravitational force exerted between them. We know it very well. Earth and Sun also have the gravitational force, and due to that reason, Earth gives that rotation around the Sun. Okay. Next force that we can consider is the electromagnetic force. Just to discuss about electromagnetic force. So in that force, we have two different branches, electric as well as magnetic. If the combined effect of electric and magnetic, that gives us electromagnetic force. Strong nuclear force. And the next one is a weak nuclear force. These two forces is related to the nuclear forces. In detail, we are also going to think about it, but a strong nuclear force is considered as a force related that nuclear particles, means fundamental particles lies within the nucleus, like the proton and neutron. That force we can also say that it's independent of the charge. Charge के साथ कोई लेना देना नहीं है. And the next one, that is a weak nuclear forces. That forces is specifically related with some kind of a nuclear reactions. So in detail, first we think about the gravitational force. As you know it, the mutual attractive force is directly proportional to the product of their masses and inversely proportional to the square of the distance between them. That you can write it. When charged particles are at rest, the force between them is known as a static electric force. That branch we consider as static electricity, or electrostatic is a much better word. About electrostatic you will study it in 12th standard, that's in the 3rd semester. Now here I can also say that when the charges are in a motion, they produce magnetic effect. But actually when the charge is in a motion, first that will produce electric current, and a wire which carry current, that will produce magnetic field. So here we can say that when the charges are in a motion, that will produce electric current, and that wire will produce magnetic force, that gives a magnetic effect. This magnetic effect gives rise to a force on a moving charge. So now that intensity of magnetic field get changed because of the motion of charged particle. So first thing is that electromagnetic force, that is about charged particle. If particle is in rest, it's a static electricity or a electrostatic. When that charged particle in a motion, that will produce current. Due to current, that gives a magnetic effect. That intensity of this field, that may be changed because of that motion of that charged particle changes. Next one, that combined effect of electric and magnetic field, that's in general, it's inseparable. Hence the combined effect of the force, that is known as electromagnetic force. I hope you understand that electromagnetic force. So, in the first chapter, whatever you are going to just come across with that new words, you will study in 11th as well as in the 12th standard. Maybe in the first semester, maybe in the second, maybe in the third, or maybe in the fourth. तो पूरा 11th और 12th आप क्या करने वाले हो वो इस चैप्टर से आपको पता चल सकता है. So there is no need to go in detail in this chapter. Next one is also, it is a very strong compared to gravitational force. Electric force between two stationary protons, for example, is 10 raised to 36 times the gravitational force between them and for any given distance. So comparatively, this force is very, very strong force. Next one, it's a strong nuclear forces. This force is basically about when you think about any nucleus. Within the nucleus, that's a proton and neutron. Proton positively charged, neutron is a neutral. But still, they just bind together. So we require that kind of the force, because that force is lies in the nature. So nature gives that idea, if we can bind proton with proton, proton with the neutron, as well as neutron with the neutron, so definitely there is some kind of the force exists which is very, very strong. So this strong nuclear force is basically that within the nucleus there must exist a strong attractive force to bind the proton and the neutron together. That's a strong nuclear force. This force is definitely independent from the charges. This force is acting between positive and neutral, and neutral and neutral. And due to that reason, that nucleus remains as it is. Here the charge independent force acting between proton-proton, proton-neutron and neutron-neutron. Within the nucleus, that is in a simple terms, you can say it's a strong nuclear force. Now, this force is 100 times stronger than the electromagnetic force. So if you just think about the sequences, gravitational force, that's considered a long range force. That we consider any two body in the universe. But if you think about the force between this pen and the cap of this pen, okay, so if you think about this pen and the cap of this pen. That's a two different body if we consider. There is also gravitational force, but comparatively that force is very, very weak force. Second, that's the electromagnetic force. Electromagnetic force is 10 to 36 times than the gravitational force. And this force is 100 times stronger than that electromagnetic force. And this force is considered a short range force. This strong nuclear force, because this force exists within the nucleus only. So here you can say that this force exists within the nucleus, so it is considered as a short range force. Now next one, it's some weak nuclear forces. About weak nuclear forces, we'll study in a 4th semester. Basically this force coming that existence when that some kind of a specific nuclear reaction will take place. Which kind of nuclear reaction will take place? Maybe you have heard about that radioactive elements or radioactive materials like uranium, radium. So that kind of elements when emit some kind of that radiations, or that gives us some kind of a decays. Decay hona, matlab kuch kam hona. Suppose that will emit beta particles, suppose that it emits alpha particles. So weak nuclear force basically we can find out when there is a beta decay will take place. In the further, you will also know about it. There are two types of beta decay, beta minus as well as beta plus. But right now for you, this is just important. The weak nuclear force appears only in a certain nuclear process, such as the beta decay. And we can also say that this force is stronger than the gravitational force, but much weaker than the strong nuclear force and the electromagnetic force. So I think you can say that it's stronger than gravitational, but weaker than gravitational and electromagnetic force. So here we have a simple relation. So most strong, you can see that strongest, that's a strong nuclear force. Second number you can give it's electromagnetic force. That strong nuclear is 100 times than the electromagnetic force. Strong nuclear, we can see it's a short range force because that force is exerted between proton-proton, proton-neutron and neutron-neutron that lies within the nucleus only. So here they mention very short range, that's within the nucleus, that's a 10 to minus 15. That operating amongst that's nucleon means proton and neutron. Electromagnetic waves or electromagnetic force. Basically, sunlight is considered as an electromagnetic force, and due to that reason you can see that range is infinite. And here that we'll study about in detail how that is effect are operating between the charged particles. But electromagnetic force is 100 times weaker than that strong nuclear force, so it's 10 raised to minus 2. If I want to say that strong nuclear force is 100 times stronger, so I can say that electromagnetic force is 100 times weaker, because here power is given with negative sign. Here weak nuclear force is 10 raised to minus 6 order, as well as gravitational force is 10 raised to minus 38 order, that's also between nucleons within the nucleus. Gravitational force is considered as a very long range force, weak nuclear very short range, and strong nuclear that is considered as a also very short range forces. Now, here we have that nature of physical laws. Same like that gravitational forces, same like that natural forces, here we have some nature of physical laws. Also we have here that 4 laws. That first one, I think you know it very well, that's the conservation of energy, law of conservation of energy. The energy neither created nor destroyed, that one form convert to another form of energy. That's the law of conservation of energy, and that you know it very well. For example, if I am getting light from the tube light, if I am getting that energy or a wind from that fan, so definitely they are consuming electrical energy, so electrical energy convert into light energy. or that provide particle to that kinetic energy. So ultimately one energy convert into another form of energy. Neither created nor destroyed, that energy remains as it is. That is called the law of conservation of energy. Second law, that is also simple, law of conservation of charge. You studied in third semester. During any process taking place in electrically isolated system, the algebraic sum of charges always remains constant. What do you mean by it? You can say that suppose if we take one wooden box, which consists electrically isolated. Suppose if I place some charges in a wooden box, if I provide some kind of energy from the outside, like a gamma rays, so gamma rays will not giving any kind of interaction with that charged particles or the charge within the wooden box. So here we can say that any process will take place outside that isolated system, that charge within that isolated system remains constant. That is the law of conservation of charge. And next, law of conservation of linear momentum. If you know that second law of thermodynamics, that is the F is equals to ma, or we can say that dt by dt, that is the rate of change of momentum. Rate of change of momentum, that is equivalent to force. Suppose if I consider force is 0, if I consider that force is 0, here we can say that momentum remains constant. ये पूरा टर्म आपको फर्स्ट सेमेस्टर के बाद अच्छी तरह से समझ में आ जाएगा, because that you are going to study in first semester. But this next one, it is also similar to linear momentum, but the name is given as an angular momentum. If the resultant external torque acting on the system 0, so total angular momentum of system remains constant. Same like the previous one. वहां पे फोर्स था, यहाँ पे टॉर्क है, ताकि वो सिंपल मोमेंटम था, यह एंगुलर मोमेंटम है. वहां पे सिंपल मोमेंटम कांस्टेंट रहता है, यहाँ पे एंगुलर मोमेंटम कांस्टेंट रहता है. दैट इज लॉ ऑफ कंजर्वेशन ऑफ एंगुलर मोमेंटम. एंड लास्ट टॉपिक हियर वी कैन सी दैट स्पेस इज homogeneous and isotropic. As result of this, we have the law of conservation of linear momentum and the law of conservation of angular momentum. And the next point is also, time is also homogeneous and isotropic. Because of homogeneity of time, we have the law of conservation of energy. So these two statements, it's a little bit important, homogeneous and isotropic. So here you can say that homogeneous means that is everywhere, if it's the same. Isotropic, if it's, you can see that that's a layer by layers, if have a same characteristics, so that is called as a isotropic. And from this one we can say that law of conservation of momentum and law of conservation of angular momentum, that's because of space is considered as a homogeneous and isotropic, while time is considered as a homogeneous and isotropic. And because of that homogeneity, you can say that law of conservation of energy, that we can also explain. So here, if you just found that in this chapter, maximum information, that 4 laws, that some important full forms, that for principles you can say that there's a laws for fundamental law, fundamental nature, and more or less we just found only informative part. So now, we are going to think about exercise question, and for your kind information, this chapter have very small exercise. Okay, so now we are going to think about exercise.